Welcome to homework.
In the question, they're asking to find the symmetric equations for the lines of intersection of the planes given by the equation 1, 5x minus 2y minus 2z equal to 1, and 2, 4x plus y plus z equal to 6. So in order to find the symmetric equations for the line of intersection of these planes, first we have to find the normal vectors of each of these planes. So the normal vector n1 for the plane 1 is equal to 5 minus 2 minus 2, and the normal vector n2 for the plane 2 is equal to 4 1 1. Therefore, in order to find the perpendicular to the line of intersection of these planes, we have to find the cross product of these two normal vectors. That is the normal vector of the line of intersection of these two planes, that is equal to, given by the table for calculating the cross product of the two normal vectors. N1 is 5 minus 2 minus 2, and N2 is 4 1 1. This is equal to 0 I cap minus 13 j cap plus 13 k cap, and therefore n vector is equal to 0 minus 13 and 13. Now a point in this line of intersection of these planes can be found by putting any value to a variable. Let z equal to 0. Therefore, in equation 1, it becomes 5x minus 2y is equal to 1, and equation 2 becomes 4x plus y is equal to 6. In order to calculate the value of x and y from the simultaneous equations, we multiply the second equation by 2 and add these equations. Therefore, the value will become, after multiplying, 8x plus 2y is equal to 12. Therefore, after adding these equations, we get 13x, y term will get cancelled out, is equal to 13. Therefore, from this we get x value is equal to 1, and putting x equal to 1 in any of these equations, we get 5 into 1 plus minus 2y is equal to 1. That is, from equation 1 we get value of y is equal to 2. Therefore, we found the points or the coordinates at the point of intersection of these planes. That is equal to 1 2 0. And in order to find the symmetric equation of the line of intersection of these two planes, the formula is x coordinate minus the coordinate at the point of intersection of these two planes for the x coordinate, that is 1, and divided by the normal vector for x coordinate. Since this is equal to 0, therefore we put x equal to 1 for the equation, and similarly for the y coordinate it is y minus 2 divided by minus 13, and for z coordinate it is z minus 0 divided by 13. Since these two values can be put in the regular form, these two can be equated, and therefore after simplifying this equation we get the value as y minus 2 is equal to minus z. Therefore the symmetric equation for the line of intersection of these planes is x equal to 1 and y minus 2 is equal to minus z. And this is the required answer of the given question.